Welcome to this lesson on Docker introduction. Now we're aware that the software development industry or the app development industry is changing, right? So we want to make things efficient as much as possible. So in this brief lecture, I'm going to talk about what Docker really is, how does it work, and the actual architecture of the Docker. I've put together about 10 or 11 slides, so it's a short lecture, but an important one. So some of the deployment and delivery challenges that we face. So for instance, we may have lots of and small changes that our software apps require. Heterogeneous platforms and languages. You may have developers that are sitting in Europe, that are sitting in US, have different platforms. Environments may be different, development, production, test. You want zero downtime, rollback capabilities, monitoring, infrastructure as code, and you want continuous delivery. Infrastructure and application metrics are also required from your apps. So these are some of the challenges that we face in today's global world where things are heterogeneous. You don't have developers sitting in just one room and doing everything right there in front of your eyes. So let me talk about the 12-factor app, which is simply a framework or methodology that was put together by the 12factor.net. You can take a look at online also for building software as a service apps that simply use declarative formats for setup automation to minimize time and cost for new developers joining the project, have a clean contract with the underlying operating system, essentially offering maximum portability, are suitable for deployment on modern cloud platforms, obviating the need for servers and system administration. In other words, sysadmin dream comes true, right? Minimize divergence between development and production environments, enabling continuous deployment for maximum agility. And you can also scale up without significant changes to tooling, architecture, or development practices. Now, these are, again, a methodology for building software apps that we must follow in an ideal environment, right? So they also list out the actual 12 factors. So starting from code base, you need one code base, tracked and revision control with many deployments, dependencies, explicitly declare and isolate those dependencies, store config in the environment, backing services, build, release, and run. So you want to be able to strictly separate those build and run stages. Processes, port binding is number 7. You want to be able to export services via port binding, concurrency, disposability. In other words, maximize the robustness with fast startup and graceful shutdown. And you want to be able to keep the development, staging, and production environments as similar as possible. Treat logs as event streams. And finally, the 12th factor is the run admin or management tasks as one-off processes. So go through these 12-factor app so that we understand the methodology and the framework. All right, really, what is the ultimate goal? So the ultimate goal is to have a single deployable file which is under version control, verified by a checksum, and simply runs without any additional dependencies. Well, this is ideal, but this doesn't really happen all the time. However, it still remains our ultimate goal as far as apps are concerned. So what is Docker? It provides a uniformed wrapper around a software package, and you can build, ship, and run any app anywhere with Docker. So think of Docker as similar to shipping containers. The container is always the same, regardless of the contents, and thus fits on all trucks, cranes, and ships. So you can have a container and you can simply take things out of the container and put things in the container, right? That's what containers are all about, and that's what Docker really does for us. So Docker allows you to package an application with all of its dependencies into a standardized unit for software development. A brief history on Docker. In 2013, released as open source, and then of course 2014 it was the 34th most starred GitHub project. Also won several awards. Docker has images. An instance of an image is a container. The last 2 points are important, and you must sort of like memorize these also, that Docker has images, and an instance of an image is a container. We'll take a look at next what those images are, what do I mean by image, and what a container is. So what are images? Simply read-only template used to create containers. So think of this as a template, right? And you create containers. You create several containers, thousands, millions, and billions. For example, Google creates 2 billion containers every week. So they're built by you or other Docker users, and they're stored in the Docker Hub or the local registry. And these images can be pulled from the registry. So once you upload them or you store them on the online registry, such as Docker Hub, for example, you can push and pull these images. Containers, on the other hand, are isolated application platform, and they contain everything needed to run your application, and they're based on one or more images. Okay, so images are created from containers, right? So they're read-only templates used to create containers. Docker Hub, as I mentioned earlier, is a cloud-based registry service which allows you to link to code repositories, build your images, and test them. You can also store and manually push images and links to Docker Cloud so you can deploy images to your hosts. Docker Hub also provides a centralized resource for container image discovery, distribution and change management, user and team collaboration, and of course, workflow automation throughout the development pipeline. So, like I mentioned earlier, think of this as just a cloud-based service where you can store all these images and you can later push these images to your hosts, whether the production environment, to the test, or to the cloud, such as your Google Cloud. All right, here's the overview of the architecture. For example, within your machine, your local machine that you're working on, you're creating this software app, you have the project code, right? What you do is you create a Docker file, which is simply a bunch of statements, right? And from those executable commands, right, using the shell, for example, you can create images, and images create containers, and everything's stored on a VM. In this case is boot to Docker, which is when you install Docker, you get to install the virtual machine also. And I'll demonstrate in subsequent lessons how to go about installing Docker. But here, just a high-level overview for understanding or conceptual understanding processes. So you know exactly how Docker works. What does it do? So once you have these images and containers on your VM, you can simply push them to the Docker Hub or Huey.io or online repository, right? So once these images are in the Docker Hub, from Docker Hub, you can export them or push them once again to the staging server, production server, or to Google Cloud or your cluster environment, where you may have thousands and millions of containers. The Nginx is simply a load balancer, also works as a reverse proxy, but primarily functions as a load balancer, which balances these containers for you. So just a high-level overview of how Docker works. How does it fit into the big picture? So in conclusion, we took a look at the deployment and delivery challenges that are faced as far as software apps are concerned and the development of software applications are concerned. We also talked about what Docker is, containers and images, Docker Hub, and the high-level architecture of how Docker fits into the big picture. Go through these slides, understand the concepts, go over the definitions, and let's move to the next lesson.